Welcome to this presentation of distance and displacement. My name is Harrison Ona, Physics and Astronomy Department, University of Nigeria. On this topic, we will address these questions. Number one question we will look at is, what is distance? What is displacement? What are their differences? What illustrations show their differences? Distance. Distance is a scalar value of how far a body has traveled, not considering the direction. It answers the question how far. It is a scalar quantity. What is a scalar quantity? Because we have said that the distance is a scalar quantity. A scalar quantity is a quantity that has magnitude, which is size, but no direction. An example of a scalar quantity will be shown so that we can be able to know really what we are talking about, what the scalar quantity really is. And you consider this, that an object which travels 4 meters without specification of direction, as shown above. The object traveled 4 meters without specifying the direction of the travel. So this is a typical example of what we're talking about, the scalar quantity. The direction is not known, and since the direction is not known and specified, then we regard it as a scalar quantity. Displacement. Let's look at what we mean by displacement. Displacement is the distance traveled in a specified direction. There is a vector value of how far a body has traveled. This means that the displacement is a vector quantity. Now here we are talking about the displacement, having in mind that displacement deals with direction. Yeah, it deals with both the magnitude and the direction. And thus we say that the displacement is a vector quantity. The vector quantity is a quantity that has both the magnitude, as in the size, and the direction. Example, let's look at typical example for us to know what we are talking about that will enhance our understanding of what vector really is. Now, the body or the object now travels 4 meters in the direction of AB, which is along east. Now, the direction of travel is known, and once the direction of travel is known, you are referring to a physical quantity that is a vector. You are no longer talking about a scalar, you are referring to a physical quantity that is a vector, since the direction of travel is specified. Now, the displacement again can also be regarded as the difference between the final point C and the initial point A of a journey. Now, we want to consider a journey. The body moves from A to B, B to C. Now you have AC. The displacement is actually AC, which is the difference between the final point C. The final point of the travel is C, is at point C, and the starting point of it is at point A. There is also a shortest distance between the 2 points, which is a straight line joining the line AC. Now, above you see that the shortest distance between the points, there are 3 points, A, B, and C. Now, we want to consider the shortest distance between the 3 points, and then we look at it and we see that it's from A to C. A, B, and C will take actually longer distance to get to a point C, while AC takes shorter distance. So distance measured along the shortest part of it is regarded as the displacement. Now, the differences between the distance and the displacement is what, again, we want to look at for us to understand the differences between the distance and the displacements. The distance, number one, the distance is a scalar quantity, while displacement is a vector quantity. Secondly, the distance is the total part covered by a body. where the displacement is the shortest distance between the final point and the initial point. Let us understand what we are talking about, considering a typical example of what we mean. A, B in a curved path is measured to be 10 meters. A, B in a straight path is measured to be 8 meters. So,